Hey geometry students, Mr. Zacek here, and we're on Unit 1, Lesson 4. We're going to look at angles today, and we're going to begin by going over some of these acute angles. So you've got your notes packet out here. We're in Unit 1. First is an acute angle. An acute angle is an angle whose whose measure, is between 0 and 90 degrees. So let's call this angle here x. And so it's important to note both of these conditions. One of the mistakes that people make with this is that they don't both say that it's greater than 0 and less than 90. So if we're going to put this in words, those two conditions would be, it has to be greater. Okay, let's see if I can write on here. Greater than 0. And the second condition would be less than 90. I got a little bit of a, my board isn't working quite right. My son wrote on it. So hopefully that can, so for an acute angle, greater than 0, less than 90. A lot of people, probably the most common error with acute angle is they just say an acute angle is less than 90, but we want to have both of those conditions. All right, a right angle here, which we use that kind of notation to represent, a right angle is exactly 90 degrees. And an obtuse angle, which we've got right here, call this x. An acute angle, just like an acute angle has two conditions, the acute angle also has two conditions, and that's greater than 90 and less than 180. And we can write that as an inequality there. And then a straight angle is exactly 180 degrees. So hopefully those are familiar terms to you. Shouldn't be something totally new, but important that we get the detail correct, all right, in those. Now, congruent angles are angles with the same measure, and just like we talked about with segments, it's the same thing here, except for when we do angle measure, we write the little like lowercase m. So the measure of angle A equals the measure of angle B. And or we could do, if we're going to do congruent, we just use the angle symbol. Angle A is congruent to angle B. All right, and one of the ways we can indicate that is this tick mark, this marking right here, and this marking right here, that indicates it. Sometimes you'll see some write them and they'll put this here with it as the first one and two, etc., etc. Okay, just like with the segments, we can take the parts and add them together to equal the whole. And with angles, we can do the same thing, the angle addition postulate. So just to mark these two different angles here, this angle here, which is ABD, and this angle here, which would be DBC, those are going to add together to be angle ABC. So to write that out, we'd say the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. And ABC is that whole big one. So the parts add together to equal the whole, and just like with segments, it's the segment addition postulate because we're adding two segments. Here it's the angle addition postulate because we're adding two angles. Okay, let's go to the next page. Now, when we're naming angles, we can name them in a bunch of different ways. So one of the things here, question, what are two other names for angle 1? Now let's get a little highlighter here, help us with this. Okay, so angle 1 is this angle right here that's created by this ray and this ray. So in addition to calling it angle 1, we could also call this angle JMK. So see how it's JM is the vertex and then it goes out to K. Or we could switch that around and we can call this angle KMJ. So the J and the K could be switched around. The M must be in the middle. Now, the second part, let's get another highlighter here for question 2. What are other names for angling this angle KML? Okay, well there it is. Well, we could do what we just did in the other one. We could name that, switch those outside letters around, L, M, K, or we've also got a number in here, and that's the number 2. We could call that angle 2. Now, would it be correct to name any of the angles M? Sometimes we can use a single letter. We did that in an earlier question. But when you have multiple angles that share the same vertex, so like angle 1 shares this vertex with M and angle 2 shares the vertex with angle M, we can't use one letter because it's not specific enough to what angle. So the reason why this is, so would it be correct to name any of the angles angle M? And the answer to that question is no. And the reason is because multiple angles, here's where my board is not working, hopefully we get it better. Multiple angles share, S-H-R-E, the same vertex. Okay. Again, I apologize for this writing here, and this board is giving me some trouble. All right, so would it be correct? No, because multiple angles share the same vertex. All right, now let's go through this next one. We're going to use a protractor here. We're going to find the measure of the following angles. All right, so this is a good idea when you're doing things, anything with angles. If you have a highlighter or a colored pen or something, to use that to help you really get this. So here we go. We've got L, it's going to go down to K, and then it's going to go up, over to N. LKN. Now, when you're reading this on the protractor, you would start from the 0 side and you come all the way up here, and notice that that's a 145 degrees. So that would be 145, which would be an obtuse angle. It's greater SE. Greater than 90, less than 180. Okay, I'm going to grab a highlighter here. Angle JKL. So if we go JKL. Ugh, that's so ugly. Let's see if I can clean that up at all. Okay, let's try this. JK. Thanks. Sometimes that straightens it out automatically for me. JKL. All right, now here we've got to kind of measure the difference, and we've gone from 45 up to 90 as that angle's across there. And so therefore that's going to be a 45 degree angle. So that would be 45 degrees. And what type of angle would that be? That would be acute. All right. The next one is what? JKN. Let's see if I can get a different highlighter here. Okay, so JKN coming down here. JKN. All right, that one is going to come across up to here. That's a 90 degree angle, which is a right angle. Okay, so 90 is a right. All right, I'm not going to do all of those. I think you kind of get the idea of what we have here, but just so recognizing that we can measure those things with a protractor. All right, let's get into some of these other type of questions. All right, number 3, synchronized swimmers form angles with their bodies as shown in the photo. If the measure of angle GHJ, okay, which is down here, and I want you to notice down here that that has 2 markings. So GHJ has 2 markings, equals 90. And the measure of angle ABC is 49. So this angle down here, if I can write it on here and it will show up, this is a 90 degree angle. Okay. And then ABC, this is a 49 degree angle. Find KLM and DEF. All right, so the idea here is to recognize that this has two markings, so that is also going to be 90, and this has one tick mark and one tick mark, and that's also going to be 49. Okay, so that's what we're getting after here in this. So the way we could write that is that the measure of angle GHJ H equals the measure of angle KLM. Okay, and the reason is because the tick marks. Ooh. Okay, so that's why. Why does that? Because of the tick marks. So therefore, the measure of angle KLM is going to equal 90 degrees. Equal 90 degrees. And kind of the same thing, you know, on the other one, that the measure of angle ABC equals the measure of angle DEF. And really, when we say those tick marks, what that is that's a given piece of information to us. So why is that true? TICK MARKS. I'm going to have to try and fix this board, see if I can get it right. My son took a colored pencil and drew all over it. That's why it's a little bit funky. So the measure of DEF equals 49 degrees. All right, so big idea from this one is just understanding that those markings tell us something about what we have here. All right, let's go to the next page. Whoops. All right, now we've got justify and explain. So when you see that word justify, what you want to think about this word justify. Justify is like the math for it. Explain means use words. Okay, justify is the math. Explain is going to use words. And I'm going to pause this video for a second and kind of fill in these explanations, because I don't want to spend all this time writing with a horrible pen, and then I'll turn it back on and I'll talk about it here for you. So be right back. Okay, I'm back now, and we've got some writing in here that hopefully we can read, and I just want to talk you through this. So if the measure of RQT, now it's important, one little detail, this looks like an O, but this is meant to be a Q. Okay, so there's our Q. So RQT, that's the large angle here. And then we're trying to find RQS, which is this smaller angle down here. RQS would be this angle, and TQS, which would be this angle. So here's how we do that. The first thing we're going to do is write out the measure of angle RQT equals 155. The measure of RQS equals 4x minus 20, and the measure of angle SQT equals 3x plus 14. All of that was given to us. The RQT was given in the statement, and then the RQS and the SQT, those were given from the diagram. And we can assume things from the diagram are given. So now we're going to use the angle addition postulate. We're going to say the measure of angle RQS plus the measure of angle SQT equals the measure of angle RQT. So what I've created here is the statement and reason. This is called a two-column format, just so that I can match up a statement with a reason. The reason answers the why question. So there's a connection here, like, why can I say this thing that I'm saying here? Well, because the angle addition postulate says that. Step 3, we substitute in 4x minus 20 plus 3x plus 14 equals 155. That's substitution. Okay, what did we do? Well, we saw we had 4x and 3x and minus 20 and plus 14. We combine like terms, which is 7x minus 6 equals 155. Simplify. Okay, so that simplifying step was really combine like CLT. Crazy pen. Okay, so what are we going to do now from step 4 to step 5? Well, we're going to add 6 to both sides. So really this, so we're going to add 6 here. we get 7x equals 161. How did we go from step 4 to step 5? The addition property of equality. Of equality means whatever we did to one side, we also did to the other. Then to go from step 5, here we're going to divide by 7. 161 divided by 7 is 23. That's the division property of equality. Now the question was asking us for the measure of angle RQS and the measure of angle TQS. And so we've already know what those are expression-wise in statement 1. We brought them in as our given. So in step 7, I'm going to substitute those in. 4 times 23 minus 20, and 3 times 23 plus 14. They're just substituting, and then we simplify, and we find that the measure of angle RQS is 72, and the measure of angle TQS is 83. Okay, so moving on to example 5. Now it says angle DEF is a straight angle. What are the measures of angle DEC? That's this angle here, and CEF. So this question is going to look pretty similar. We just have one little piece of information that's different. So I'm going to start off by writing in our givens. Angle DEF is a straight angle. The measure of DEC is 11x minus 12, and the measure of CEF is 2x plus 10. Again, given, some in the statement, some in the diagram. I'm going to use the angle addition postulate. Measure of angle DEC plus the measure of angle CEF equals the measure of angle DEF. That's the angle addition postulate. And now step 3, here's where that straight angle definition comes in. The measure of angle DEF is 180. Why do I know that? A straight angle measures 180. So we substitute in, look at our like terms. What do we have here? 11x and 2x. And then we've got minus 12 plus 10. 11x plus 2x is 13x. Negative 12 plus 10 is negative 2. That's simplify. We're combining like terms. How do we move from step 5 to 6? Well, what do? We add 2 to both sides. So plus 2 plus 2. We're left with 13x equals 182. Addition property of equality. We divide both sides by 13. 13 divided by 13 is 1x. 182 divided by 13 is 14. That's the division property of equality. And then there we are again. We substitute it in. And then we should have our last step here, step 9, of simplifying this. So the measure of angle DEC equals, all right, so that's going to be 11 times 14 divided by, or minus 12. So 11 times 14 minus 12 is 142. So that would be 142. And the measure of angle CEFE, make sure you're using capital letters with those, is 2 times 14 is 28. 28 plus 2 is 38. And you want to make sure that those numbers add together. That looks like a 5, but that's really a 3. 38. Okay, and why did we do that? Well, we just, step 9 is simplify. Simplify. Okay, so you got a reflection there for you to do, but that completes our lesson. Thank you so much.